Friends, all of you, good evening. Welcome to the session. Continuation of chapter 1, that is Fundamentals of Electrical Circuits. I'm starting lecture 13 on fundamentals. Before starting the different models of questions with respect to connection of elements, here I have to discuss small concept. This is also very important for any competitive exam point of view. This you have to concentrate as a note point. It's a concept of bridge circuit. Concept of bridge circuit. So for example, if any bridge circuit is given like this, let's concentrate. This is one bridge circuit. That this is R1 and this is R2, this is R3, and this is R4. Okay. That there is one resistance R5 resistance. If the resistances are given, impedances are given, this concept is applicable. Let the source is connected here. At balance condition, if you let's consider two cases that I have to explain here. One is a balanced condition and another one is unbalanced condition. That is, if the bridge is balanced at balanced condition, no need of any proof. Directly you have to remember like this. Product of opposite resistances are equal. That is R1 into R3 equal to, you have to multiply product of opposite, then it is equal, then we can say that bridge is balanced. That this voltage is R1 into R3 equal to R2 into R4. This is one observation at balanced condition. Then at balanced condition, let the current through this resistance is I5. Let that current is I5. Then I5 equal to 0. There is no current through the resistance. That means this between these two nodes, source is connected. Remaining two nodes, resistance or any galvanometer or any ammeter is connected. The current through that element is 0 if the bridge is balanced condition. But condition is source is connected between these two nodes. Remaining two nodes only, the element is connected. Not for the same terminals. We never connect this element and source for the same terminals. If source is connected between these two nodes, then the element is connected between these two nodes. You can interchange also. If the source is connected between these two nodes, between these 2 points, then this element is connected between these two elements. But in which branch current is 0? The element which is connected, the nodes other than the source is connected. Not for the source is connected. The nodes which are source is connected. That's why the current is 0, not between these two nodes. The current is 0 between these two nodes. That is important observation. That is, at balanced condition, product of opposite resistances are equal. At balanced condition, if the current is 0, then no need to consider this element. You have to remove this element. Then during simplification, then remove R5. Because there is no current to the resistance at balanced condition. If this R5 is removed, then if you have to calculate R equivalent, whenever this R5 is removed, if you have to calculate R equivalent, this R1 and R4 is series, R2, R3 is series. Then by removing the R5, if you draw the equivalent, this is the point. This is R1, this is R2, this is R1, this is R2, and this is R4, and this is R5. This is R4, sorry, this is R3. Then what about R1 and R4 series? Then you have to calculate the R equivalent equal to R1 and R4 is series, R1 plus R4. That is in parallel with the R2 and R3. That is R2 and R3 is also series. These two are series and these two are series, but these two combinations are parallel. Like this, you have to analyze at a balanced condition. This concept is applicable not only for resistances, even impedances are given also. This concept is applicable. You write in terms of impedances, then Z1, Z3 equal to Z2, Z4. Z2, Z4. Even admittances also it is applicable. Y1, Y3 equal to Y2, Y4. Even resistances are given, impedance is given, admittance is given. This condition is applicable. This is at bridge is balanced condition. When we can say that bridge is balanced condition, there is no current through this resistance. When the current through this resistance is zero, product of opposite impedances or resistances are equal. That is product of opposite resistances are equal. This is a balanced condition. But very important for 2 marks question, if the bridge is under unbalanced condition, total. But point to remember, students, at balanced condition, the voltage across the, let for example, this is A, this is B, you have to take this is C, otherwise you take like this. I'm taking this is A and this is B, VAB, then this is CD. Between A and B terminals, between A and B points, R5 is connected. I5 is 0 means what is VAB? VAB is also 0. VAB, that is VA minus VB equal to 0. That is voltage across this R5 resistance is also 0. At which condition? Balanced. If the bridge is at unbalanced condition, at unbalanced condition, how to analyze? At unbalanced condition. Unbalanced condition. Take the same bridge. This is R1 and this is R2, R4 and this is R3. Let the source is connected between these two nodes or between these two terminals. Let this is R5. This is R1. This is R2. This is R3 and this is R4 and this is R5. At this point is A and this point is B. This is B. Then at unbalanced condition, when the bridge is unbalanced, how to identify? You take the product of opposite resistances. If it is not equal, then we can say that bridge is at unbalanced condition. That is, bridge is not balanced. At unbalanced condition. At unbalanced condition. That is R1, R3 not equal to R2, R4. If R1, R3 not equal to R2, R4, there exists a current to that 5 ohm R5 resistance, that is I5 not equal to 0. Then VAB is also not equal to 0. In calculation of equivalent resistance, we have to consider R5 also. We have to consider R5 also. In calculation of, don't remove that R5. If the bridge is under unbalanced condition, you have to consider R5 also. See, for example, the same circuit I'm drawing like this. I will draw like this. So this is R1 and this is R4. This is R1, this is R4. And this is R2 and this is R3. So R3. This source is connected here. This is this. Now you have to find what is the voltage across these terminals. What is the voltage across this R5 resistance? Let this is A, B. You have to find VAB. That is VAB you have to find. Then to find VAB, you can apply KVL either upper side or lower side. We can get same answer. Let, for example, this I am taking, let this is I am taking positive, negative, VA, positive, negative, VB. Take this KVL. Apply KVL. Then if you apply KVL, then what you can get? Positive to negative minus VAB. Positive to negative minus VB. Negative to positive plus VA equal to 0. From this, what is VAB equals to? VA minus VB. Now to apply VAB equal to VA minus VB. Now I have to calculate what is the voltage across. I have to calculate VA. VA is nothing but a voltage across R4. Voltage across R4. Apply the voltage divider rule. If you have to calculate voltage across R4, that is V into R4. This is important for 2 marks more. V into R4 by total voltage into this resistance by these two are series. You have to take R1 plus R4 minus. You have to calculate voltage across R3. VB is nothing but voltage across R3. Voltage divider rule, students. V into R3 by R2 plus R3. R2 plus R3. Clear? Like this, you have to calculate the VAB. This is important. Sir, no, sir, I don't want to apply KVL here. I have to apply the KVL in upper side also. Apply same. If you have to apply the upper side also, you can get same answer. Any formula you can get the same answer. See, for example, let this is you have to take VA dash. This you have to take VB dash. Then apply KVL here. KVL you have to apply. If you apply KVL, positive to negative, minus VB dash. Negative to positive, plus VAB. Negative to positive, plus VA dash. Equal to 0. Then from this, what is VAB equal to? VB dash minus VA dash. You can get same answer. VB dash minus VA dash. VB dash minus VA dash. Then how to calculate VB dash? How to calculate VB dash? VB dash means voltage across R2 resistor. That is V into R2 by these two series R2 plus R3. Voltage division rule. Minus. How to calculate VA dash? VA dash is nothing but voltage across R1. That is V into R1 by these two series R1 plus R3. Yes, friends. Either apply this formula or VAB formula, we can get same answer. This one and this one is same. Finally, how to check the answer? Then we can get the same answer. Clear, students? If any bridge circuit, two cases. Bridge is balanced, then voltage across this element is 0. Current through this element is also 0. How to say that bridge is balanced? This product of opposite is equal. Product of opposite is equal. At that point you have to. But point to remember, students, this bridge circuit we can also draw like this. Every time don't expect like this only. This also same. There is a different ways of representing this. Later on I will give. This is R1 and this is R2. Okay, and this is R4 and this is R3. This is R4 and this is R3. Between this there is R5 resistor. There is a different ways of, and between this there is a source. Like this also it is correct. There is a different ways of representing this. Later on the but these 2 points you have to mainly concentrate. The bridge is balanced condition. If the bridge is unbalanced condition, then how to calculate under unbalanced condition? How to calculate voltage across that element? Voltage across that element is calculated using this formula or using this formula. You can get same answer. Just you have to apply KVL either bottom loop or upper loop. In both the cases, you can get the same answer. That point we want to concentrate. Clear? Yes. Now with this knowledge, just I am giving one problem. Can you check it? Check your knowledge. For example, if it is given like this, this is 100 volts. This is 100 volts. And this is on bridge circuit it is given. So given bridge circuit. Here the source is connected. And this is 10 ohms. And this is 15 ohms. And this is 6 ohms. And this is 8 ohms. If it is asking that what is V0? Asking that what is this V0? First take the bridge is balanced. 10 into 8 is not equal to 15 into 6. 80 is not equal to 90. Bridge is unbalanced. Bridge unbalanced. You have to apply for either bottom loop or you have to apply either top. Then you have to calculate this is the A and this is B. Then VAB is nothing but that is VA minus V0. That is VA minus VB. Then how to calculate VA minus VB? VA is nothing but 100 into voltage across this resistance like this. Apply this. V into R4 now. This resistance, voltage across this resistance, total voltage across this resistance, total 6. Or you can also apply in upper loop voltage across this resistance minus voltage across this resistance. Okay. I'm applying for bottom loop 100 into resistance. Voltage across 6 ohm resistor. 100 into 6 by 10 plus 6. 10 plus 6 minus 100 into 8 by 100 into 8 by either top you take or I'm taking bottom. 100 into 8 by that you have to write 100 into 6 by 10 plus 6, 100 into 8 by 15 plus 8, 15 plus 8. Then you have to simplify this one. Then V naught equal to, that is VAB. How much you can get? It's approximately equal to 2.71 volts. You can get 2.7. This is the final answer. No, sir, I have to apply for upper for this one, upper loop. Then you can, upper loop means first you take this one. Because this I already given a KVL. VB dash minus VA dash. Then you can also apply like this. V naught equal to 100 into 15 by 15 plus 8. 15 plus 8 minus 100 into 100 into 10 by 100 into 10 by 10 plus 6. 100 into 10 by 10 plus 6. Then also you can get 2.71 volts. You can also get a 2.7 volts. How to check it? Either apply like this or like this. Finally, you can get the same answer. Simple, sir. Easy to remember. No need to remember the formula also. For this case, if it is asking what the voltage, bridge is unbalanced, then only voltage is exists. Then you take either bottom loop or upper loop. Once you take the bottom elements, 100 into 6 by 6 plus 10 minus 100 into 8 by 8 plus 15. If you take top loop, 100 into 15 by 15 plus 8 minus 100 into 10 by 10 plus 6. Right? How to apply this one? Or you can apply this one. Okay. This is one model of question that you have to concentrate. But I told already, this bridge can be represented in different ways, whatever the bridge I given. But don't think like this, always source is connected between these two terminals, the element is connected between. No, you connect sources between these two terminals also, but element is connected between these two terminals. Okay. Bridge is balanced, not current through the source. The current through the element only is not current through the source. That point of view. This is the bridge that you have to concentrate. This is the bridge source. But if the bridge is balanced condition, this is the node point. This also bridge, this also bridge representation, this also bridge representation, this also bridge representation, this also bridge. Let bridge is at balanced condition. At balanced condition. Balanced condition means, for example, I take an R1 equal to R, R2 equal to R, R3, R4 equal to R. Then bridge is balanced means this R into R, R square, R into R, R square. In every case, the bridge is balanced. This is the balanced bridge. This also balanced bridge. This also balanced bridge. You can check it. I taken the balanced bridge. Then if the bridge is balanced case, for this type of circuits, again, no need to simplify. Simply remember like this. R equivalent becomes R1. For all these bridges, R equivalent equal to R source. How to check it? If you want that, see for example, I'm calculating what R equivalent for this. If the bridge is balanced, then there is no current through this resistance. You have to neglect this R5. Then these two are series, these two are series. R plus R, 2R. This is R plus R, 2R. 2R, 2R parallel. If 2R, 2R is parallel, then resultant is R only. Clear? These two are series. These two are series now. That is R plus R, 2R. And these two also series. R plus R, 2R. Then 2R in parallel with 2R. If 2R is in parallel with 2R, if two equal resistances are parallel by 2, that is R only. That's why for all these networks, if it is a balanced network, for all these balanced circuits or networks, balanced circuits, R equivalent equal to R1. If you want to write, in every case you can get the R equivalent equal to R. This and this is same. This and this also same. This and this also same. All these forms indicates the bridge circuit. Then what are the R equivalent? We can get the R. That means if the circuits are given like this, directly you can answer R equivalent equal to R. Clear? That you have to concentrate. In the following circuit, if each resistance is 10 ohms, the resistance across AB terminals is. You have to calculate what is the resistance across AB terminals. Can you check it? What the resistance across AB terminals? This is AB. What is the resistance across AB terminals? Not this is AB, not this one. This one is AB. This is A and this is B. Can anybody answer this? What is the resistance across AB terminals? Given that all are 10 ohms. All are 10 ohms means this is 10 ohms. This also 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 10 ohms. Then you have to check the balance condition. Product of opposite. 10 into 10 equal to 10 into 10. Friends, bridge is balanced. Bridge is balanced. If bridge is balanced, we have to remove the element not for the source connected terminals. This is source connect. Don't remove this resistance. You have to remove this resistance because the current through this resistance is 0. Don't take these terminals. This resistance, current, then you have to remove this one. Once you remove that resistance, then redraw the circuit. This is 10 ohms, and this is also 10 ohms. I'm drawing the once again, and there is a resistance of 10 ohms, and this resistance also 10 ohms, and this also 10. This is the equivalent. How to find what is the resistance across AB terminals? This resistance across AB terminals. How to find RE? Yeah, this is 10 ohms, and this is also 10 ohms. This is 10 ohms. This also 10 ohms, and this also 10 ohms. And what are the final answer, friends? Is it 5 ohms? 10 ohm, 10 ohm. This 2 is series. This is 20 ohms, and this is 20 ohms, and that is 20 ohms in parallel with 10 ohms in parallel with 20 ohms. Very good. I'm calculating R equivalence. This 20 ohms parallel. You have to take 10 ohms. 20 ohm parallel is 10 ohms. Then 10 ohm is parallel. 10 ohm is parallel finally. Very good. 10 ohm is parallel. Then we can get 5 ohms. Correct? Correct. The R equivalent equal to 5 ohms. All of you got this? Clear? This is 20. This is 20. 20, 20 parallel. 10. 10, 10 parallel. 5. If equal resistances, two equal resistances are parallel, na, by 2 only. Okay. Who told the answer? That is 5 ohms. That is correct answer. Right. Can anybody answer this one? This also 3 ohms. It's very simple. We can draw the circuit as a bridge circuit. How to draw? It's very simple. Take this is the A, this is A, and take this is the B. This is B. Here, concentrations. This A from A to B. A to B. A to B, 3 ohm, 3 ohm. A to B, 3 ohm, 3 ohm. And this also. A to B students. You have to take it up. A to B, it's a 3 ohm, 3 ohm. And this is A to B. This is A to B. No? 3 ohm, 1 ohm. From point A to B. 3 ohm, 1 ohm. Next A to B, 3 ohm, 3 ohm. Then shall I draw like this? From A to B, let this is the 3 ohm and this is the 1 ohm. Next A to B, this is 3 ohm and this is also 3 ohm. This is 3 ohm, this is 1 ohm, and this is 3 ohm and this is 3 ohm. From A to B. Then between this, how much resistance? 3 ohm resistance. This is the 3 ohm resistance. Can you check the bridge is balanced or not? 3 into 3 is not equal to 3 into 1. That is bridge unbalanced. Bridge unbalanced. Right. Now, how to simplify this one? It's also very important. Once again, I'm drawing this one. This is the 3 ohms. And this is 1 ohm. And this is the 3 ohms. And this is the 3 ohms. And this is 3. This is 3. This also 3. This is 3. This also 3. This is 1. This is A and this is B. To simplify this, one method is you have to convert simply like this. This is a delta connection. You have to convert delta to star. Do like this. Delta to star. Friends, in delta to star conversion, if you convert delta to star, if it is a resistances, all are equal resistance. If it is equal resistance, it becomes by 3. That is, in delta to star conversion, I given this statement. In delta to star conversion, resistance and inductances are becomes by 3, capacitance becomes 3 times. Or otherwise, how to calculate? For example, this is a RA, that this is a RB, that this is RC. Can you tell me what is RA equal? Directly also you do by 3 by 3 by 3. It's a 1 ohm. RA, if you want delta to star conversion, 3 into 3 by total 3 plus 3 plus 3. How much? 1 ohm. What is RB, friends? Product of opposite. RB. 3 into 3. 3 into 3. This one. 3 into 3 by 3 plus 3 plus 3. Actually, no need to do this one. Directly you take by 3 only. In delta to star conversion, if it is equal resistance, it becomes by 3. If it is equal resistance. If you want RC, 3 into 3. This I already given yesterday session. How to convert delta to star, star to delta. Then 3 plus 3 plus 3. This is equal. Then after converting delta to star, then this is 1 ohm, this is 1 ohm, this is 1 ohm. I'm drawing like this, equivalent after converting delta to star. This is 1 ohm, This is 1 ohm. And we are getting like this. This is 1 ohm. And this is also 1 ohm. This is star equivalent. This is 1. I am replacing this delta by this total delta by this star. Then remaining is this is 1 ohm. And this is 3 ohm. This is 1 ohm and this is 3. Now tell us what is the final answer? What is RA or R equivalent? Then 1 ohm, 3 ohm is series. This is 4 ohms. This is 2 ohms. 4 ohm, 2 ohm is parallel. This 1 ohm is in series. 1 plus 2 in parallel with 4. 1 plus 2 into 4 by 2 plus 4. How much you get? 1 plus 8 by 6. That is 14 by 6 ohms. 14 by 6 ohms. This is equal to 7 by 3 ohms. All of you got? If the bridge is unbalanced case, if this resistance is present, better to go for this method. You have to make the star to delta. Either you convert delta, this side delta or this side delta, any delta, convert into star. Let's convert into star. That is the best method. Clear? That you have to concentrate. Next. Can anybody answer? In the following circuit, if each resistance is 20 ohms, equivalent resistance between terminals A and B, you have to find what is the resistance between terminal A and B. Each resistance is 20 ohms. If each resistance is 20 ohms. Now, what is solution for this? It's very simple. This is 20 ohms. Each resistance is 20 ohms. This is 20 ohms. This also 20 ohms. This also 20 ohms. This also 20 ohms. This also 20 ohms. And simple observation here. You have to check. You have to take this is one bridge. This is one bridge. If it is a bridge, check the product of opposite. 4 arms now. 1, 2, 3, 4 arms. Product of opposite. 20 into 20, 20 into 20. Equal to 20 into 20. That is bridge is balanced. Bridge is balanced. If the bridge is balanced, don't consider this resistance. Remove that resistance. If you remove that resistance, then what is the equivalent? This 20 ohms is series. Next, this 20 ohms also series. And this is 20 ohms. You have to find this is resistance between RAB. This is 20, this is 20, this is 20, this is 20, this is 20. Can anybody tell what is RAB? That is R equivalent terms. 20 plus 20, 40. This 40, 40 in parallel. 40 in parallel with 40, in parallel with 20. 40, 40 parallel 20, 20 in parallel with 20. This is equal to 10 ohms. Finally, I got 10 ohms. Is it correct? Very simple. How to apply the bridge balance here? Then remove that 20 ohm resistance. We are getting the, this is equal to 10 ohms. Clear? Okay. Can anybody answer this question? This is 3 ohms, and this is shorted. I told already, you have to form this is the bridge. Let this point is A, and this point is B. This 3 ohms shorted. Connect here. This is 3 ohms, and this is shorted. Next, A to B. This is no element, and it is a 3 ohm. No element, and it is a 3 ohms. So that is 3 ohms. B side 3 ohms. This B side 3 ohms. See, A side 3 ohms. Next shorted. B side 3 ohms. Next shorted at A side. Like this. This is 3 ohms. This also 3 ohms. And between this, it is a 3 ohms. Now, see this one, students. What is the observation here? Can you draw like this? This 3 ohms, this is directly connected to this one. And this 3 ohms also directly connected. I am drawing like this. This is the 3 ohms. This is the 3 ohms. And this is the 3 ohms. Correct? You connect this 3 ohms directly here. This is 3 ohms. And you connect this 3 ohms here. All are parallel. 3 ohm, 3 ohm, 3 ohm is parallel. If you want like this also, you can draw. You can draw like this also. This is 3 ohms between A and B now. This is 3 ohms. And between A and B, this is the 3 ohms. This one. And this also 3 ohms. This is A and B. All are parallel. Then what is the R equivalent, friends? That is 3 by 3. This is equal to 1 ohm. Very good. Clear? Concentrate how to proceed to solve the bridge type questions. Next. Can anybody answer this? Come on, do it. I'm expecting answer from you. What is R equivalent? What is RA? Yes. What is the solution for this? 2R is series. This totally 4R. Shall I draw like this? This 2R is 4R. I'm drawing like this. 4R. I'm redrawing the circuit like this is R, and this is 2R. This is 2R. Actually, between these 6R is connected. I'm drawing the 6R like this. This is the 6R. And this is the 3R. This is 6R. Okay. And this is A and this is B. And this 4R, I'm drawing 4R like this. This is 4R. And this 2R is also connected here. This is 4R. The same circuit only I'm drawing like this. So, yes, friends. Now you have to check it. This 4R is parallel. This is how much? 2R. R equivalent equal to 2R. R plus R 2R. 2R is parallel. This is how much? R. Shall I draw like this? This is 6R. This is R. This is 2R. As it is 3R, I'm right. This is 3R. This is A and this is. Come on, friends, what is R equivalent? R, 2R, 3R. This is 6R. This is 6R. 6R in parallel with 6R. 6R in parallel with 6R. This is equal to how much? It is a 3R. Right. It's a 3R. Clear, friends? Just see the network. How to see this point is same. This is the same node. It's totally same node. You have to connect here or connect here. At any point you have to connect. And this totally the same node. You have to connect here, connect here, connect here. At any point you have to. Then it is 3R. Can anybody answer this? RAB. Come on, do it. Calculate. See, I'm drawing this network like this. Shall I draw like this? This is A and this is B. At A, the resistance is 2 ohms. At B, the resistance is 8 ohms. Yes. From A to B, final A to B, you have to take the path. A to B, you have to take the path. This is one path. That is 15 ohm, 10 ohm is series. 15 ohm, 10 ohm is series. That is one path. 15 ohm, 10 ohm. 15 ohm, 10 ohm is series. That is one path. Next. See the one more path. A to B path I'm checking. A to B path I'm checking. This one. Take this A to B. That is 30 ohm, 20 ohm series. 30 ohm, 20 ohm is series. 30 ohm, 20 ohm is series. Next, one more path. Check it. A to B or B to A. You take any path. Even you have to take the B to A. I'm taking this one. Or A to B or B to A. Which is series? 40 ohm, 10 ohm is series. 40 ohm, 10 ohm is series. That is, this is 50 ohms. This is also 50 ohms. This 50 ohms parallel, 25 ohms. This is 25 ohms. Can I draw like this? This is 2 ohms. This is 25. This is 50. This also 50. And this is 8 ohms. This is 2 ohms. This is 8 ohms. This is 50. This also 50. This is 25. This 50, 50 parallel 25. this 25 parallel 12.5. Then this is 2 ohms, this is 12.5, and this is 8 ohms. 2, 8. 2 ohms, 12.5 ohms, 8 ohms. This is A, this is B. Now finally you tell me what is RAB, students? What is RAB? Finally, come on. 2 plus 12.5, 14.5, 14.5 plus 8, 22.5 ohms. This is the RAB. It is equal to 22.5. Very clear. Just check the path. A to B path, series path or parallel path. I take a, this 15 ohms, 40 ohms, 10 ohms is series. 40 ohms and 10 ohms is one path. 30 and 20 is one path. 15 and 10 is one path. How to check it? Then that is the answer. Can anybody answer this? Here separately it is asking what is the equivalent resistance across RB, what is the equivalent resistance across BY, what is the equivalent resistance across RY steps. Can anybody answer this? This model also very important. Come on, do it. See, for example, if you have to calculate what the equivalent for RB equivalent resistance, then you take only RB path. This is RB. I am drawing this. This is 3 ohms, and this is 30 ohms, and this is 2 ohms. If it is RB path, then in RB don't consider Y. There is no current to Y. But only Y means only this element is removed. But whenever current is flowing like this, there is a current division here. Then this 40 ohms and 50 ohms is series. And that comes 90 ohms. 90 ohms is in parallel with 30 ohms. Clear, sir? This RB that taken only if you want RB equivalent, then there is no current to Y. Then, but this element is connected to this branches now. That's why this 40 ohms, this 50 ohms. But Y is open circuit. That's the meaning. Y is open circuit. But current will flow like this in this part. Then this 40 ohms, 50 ohms is series. This 90 ohms. Now 90 and 30 is parallel. This 90 and 30 is parallel. Now what is the RB, students? 3 plus 90 into 30 by 90 plus 30 plus 2. Then how much you can? That is 2700 by 120 plus 2. This is approximately equal to 27.5 ohms you can. Is it correct? 27.5 ohms. This is RB. Clear, students? That is how to answer. So for example, if it is asking that BY, can you try for BY? BY. BY means you have to take the current through only B and Y. Remove the R. BY. Take like this. This is BY. That is 2 ohms. Yes, friends. This is 2 ohms. And this is 40 ohms. And this is 1.5 ohms. 2 ohms, 40 ohms, 1.5 ohms. But if you take BY, this 30 ohms comes in series with 50 ohms. Because there is no current through R. Then this is 80 ohms. 80 ohms. Now calculate what is BY. BY equal to 2 plus 40 and 80 is parallel. 40 into 80 by 40 plus 80. This is in series plus 1.5 ohms. Can anybody? 2 plus 40 into 80 by 40 plus 80 plus 1.5. So this approximately equal to how much you can get? I'm doing the calculation. 2 plus 40 into 80 by 40 plus 80 plus 1.5. This approximately equal to 30.16 we can get. 17 ohms. Is it correct? 30.17. Can you try for RY, students? Come on, do it. RY. RY means you have to take the current only in this path. This RY. RY. This is 3 ohms. And this 30 ohms. 30 ohms. And this is 40 ohms. 40 ohms. And this is 1.5 ohms. This 50 ohms is totally parallel. This 50. Then what is RY, students? 3 plus 30 plus 40, 70. 70 in parallel with 70 in parallel with 50. 70 into 50 by 70 plus 50 in series with 1.5. Then how much RY you can get? What is RY? 3 plus 70 into 50 by 70 plus 50 plus 1.5, students. This approximately I got 33.7 volts or 33.67 lines. Then RB equal to 27.5 ohms. Py equal to 30.17 ohms and Ry equal to 33.7 ohms. 33.7 ohms. Clear? Check it. Next, these are some how to calculate the equivalent resistance in some examples. And one more important model is ladder network. How to solve the questions based on the ladder network. This is also very important model when you forget at the ESC point. If any question is framed on ladder network, identify the repeating unit in the network. You have to identify the repeating unit in the network. From infinite ladder, if you remove one unit, R equivalent remains same. Here it is given as infinite. From infinite, if you add one unit for infinite, it is also infinity. From the infinity, if you remove the one unit, it is also infinity. That means there is no change in the equivalence. There is no change in the equivalent. From the infinite network, you remove the one unit or add the one unit. There is no change in the R equivalent. There is no change in the R equivalent. That's why in the total, I'm taking the repeating unit. RA, RB, RC. RA, RB, RC. This is the repeating unit. How to solve the ladder network problem? This is the repeating unit. You have to take this R equivalent. If you remove that one, and you take this is the total is R equivalent. This is R equivalent. Shall I draw like this? I'm taking that removed network. This is RA. This is the procedure to calculate the resistance, equivalent resistance in ladder networks. This is RB and this is RC. This is RC. This is R equivalent. This total I'm replacing as a R equivalent because this total is the R equivalent. Finally, how to find the R equivalent? Then from this, what is R equivalent? This is the procedure to solve the ladder network. What is R equivalent equal to? RB and R equivalent is parallel. Shall I write like this? RA plus RB in parallel with R equivalent plus RC. Then you have to simplify this. R equivalent equal to RA plus RC plus RB into R equivalent by RB plus R equivalent. RB plus R equivalent. Then from this, R equivalent minus, you bring this term this side. How to answer this one that I'm explaining? RB into R equivalent by RB plus R equivalent is equal to RA plus RC. RA plus RC. Then you have to simplify this, cross multiply. This is R equivalent into RB plus R equivalent. Cross multiplying this into this, minus RB into R equivalent is equal to RA plus RC. RA plus RC into RB plus R equivalent. RB plus R equivalent. Then multiply this RB into R equivalent plus R equivalent square minus RB into R equivalent, RA into RB, RA into RB plus RA into R equivalent, RB into RC plus RC into R equivalent, RC into R equivalent. Then you have to write like this. RB into R equivalent minus RB into R equivalent is cancelled. Then R equivalent square equal to. Shall I write like this? This RA plus RC. R equivalent is common. RA plus RC into R equivalent. This R equivalent is. And from this you have to take the RB is common. RB is common. RB into RA plus RC. You bring this side. This is R equivalent square minus. But no need to remember this formula. Just concept I am giving. RA plus RC into R equivalent minus RA plus RC into RB equal to 0. This is the quadratic equation, friends. By solving this equation, we can get the R equivalent. Take the positive values. Okay. This is by solving. This is just like ax square plus bx plus c equal to 0. This is one quadratic equation. By solving this equation, no need of any solution. By solving this equation, we can get R equivalent. R equivalent. But take only positive values. Don't take the negative values. Quadratic equation means two roots you can get. In that, you have to take only positive values. But take only positive values. because R equivalent is the resistance value. Resistance never be negative. I told already. Resistance is always positive value. That's why you have to take the only positive values. But no need of finding the solution for this. If any problem is given, this is the procedure you have to apply. That is the main. Say for example, if it is given like this 1 ohm, 1 ohm, 1 ohm is also 1 ohm. Then in this you have to find the what is the R. What is the procedure? You first identify the repeated elements here. This is the repeating. 1 ohm, 1 ohm, 1 ohm is repeated. Then remove that one. You have to take this is the R equivalent. Then to find this, I'm taking removed one is this is 1 ohm, and this also 1 ohm, and this also also, and I'm replacing with R equivalent. This is R, and this also R. Then what is R equivalent? This R equivalent equal to 1 plus this 1 and R equivalent is parallel. 1 into R equivalent by 1 plus R equivalent plus 1. Then R equivalent equal to 1 plus 1 2, 2 plus R equivalent by 1 plus R equivalent. So I have to cross multiply. R equivalent into 1 plus R equivalent is equal to 2 into 1 plus R equivalent plus R equivalent. Then multiply this R equivalent plus R equivalent square equal to 2 plus 2 into R equivalent plus R equivalent. Then this R equivalent cancel. Then you have to write this R equivalent square minus 2 into R equivalent minus 2 equal to 0. Then from this you have to find the what is the R equivalent. Find the roots for this. Come on, do it.
Sir, your mic is off.
Sorry. Then R equivalent equal to 2 plus R minus B square minus 4A. B square, that is 2 square minus 4A. A is how much? 1. C is minus 2 by 2A. 2 into 1. This coefficient is 1. But the R equivalent equal to 2 plus R minus square root. 4 plus 8, 12. 12 by 2. R equivalent equal to 2 plus R minus, that is 2 root 3 by 2. Then you take the 1 plus R minus root 3. 1 plus R minus root. Then take the positive value. If you take the positive value, 1 plus root 3. 1 plus root 3. Root 3 is 1.732 now. 1 plus 1.732. 2.732. This is correct answer. 2.732. It is option A is correct. Is it correct? It's not 2.23. We got 2.732. Thank you. Yes. It's 2.73. You take the only positive value, don't take the negative value. If you 1 minus root 3, you get negative value. Then you take the positive value. Like this, you have to proceed. Any network is given. This is the way, any ladder network, if you have to solve, this is the process. Can you try this? First, identify the repeating elements. Repeating elements. This 2 ohm and 1 ohm is repeating. Then remove that element. This is 2 ohms. and this is 1. Remaining is RT. Because RT is given, you take RT. If R equivalent, take R equivalent. Any notation is given, that notation is R. This I am taking, this is R. This also R. R total or R equivalent. And same procedure, what is RT equal to source? 2 plus 1 ohm and RT is parallel. 1 into RT by 1 plus RT. Cross multiply. RT equal to 2 into 1 plus RT plus RT by 1 plus RT. Very good. That is answer. That is correct. 2 points. Yes. Cross multiply. That is RT into 1 plus RT is equal to 2 plus 2RT plus RT. RT plus RT square 2 plus 2RT plus RT. RT cancel. Then RT square minus 2RT minus 2 equal to 0. Same quadratic equation. We are getting same equation. Also same. Then RT equal to 2 plus R minus square root B square minus 4AC. 2 square minus 4 into A into C is minus 2 by 2A. 2 into 1. So this RT equal to, we can get 1 plus R minus root 3. This is equal to 2.73. Can you check it? Even for capacitances also, same procedure. Yes. Identify the repeating elements here. When capacitance is given, resistance is given, same procedure. But in equivalent, if capacitors are series, capacitors are parallel, how to calculate that? That only will change here. But concept is same. This is repeating. Remove that repeating element. This is C. And this also C. And replace this is by CT. CT. And this also CT. Then CT equal to, these two are parallel. These two are parallel. But if the capacitances are in parallel, directly you can add C plus CT. Correct? This is parallel. And C and C plus CT is series. C and C plus CT series. Students, don't confuse. C and CT is parallel. Parallel of capacitance is similar to series of resistance constant. Directly you can add. But C and C plus CT is parallel. Then parallel means capacitor series. C and C plus CT is series. Capacitance series is similar to resistance parallel constant. Okay. Then this is CT. Then you have to simplify this. Come on, do it. CT equal to, that is a C square plus C into CT by 2C plus CT. Cross multiply. 2C into CT plus CT square is equal to, this is C square plus C into CT. But here this C value is 1 farad. Please check it. Yeah, no problem. That you are getting. This is equal to 1 farad. This is 1 farad. Or if value is not given, also no problem. Direct also you can. This is 1 farad. Okay. Then if C, direct also you can solve, but C is given 1 farad. If C is 1 farad, 2 into CT plus CT square, 1 square plus 1 into CT. That is CT square. This is CT, this is 2CT plus CT minus 1 equal to 0. Minus B plus R minus square root of B square minus 4AC by CT square plus CT minus 1 equal to 0. Then minus B. What is CT? Minus B. This is 1. Minus 1 plus R minus square root B square. 1 square minus 4AC by 2A. 2 into 1. Minus 1 plus R minus square root. This is minus 1 root 5. This is minus 1. This is root 5 by 2. Then what is CT? 1 minus 1 plus R minus root 5 by 2. You take the positive value. Minus 1 plus root 5 by 2. What is CT you can get? Minus 1 plus, what is the root 5 value? Do it, all of you. 2.236. 2.236 by 2. Then what is CT equal to? minus 1 plus 2.236, 1.236 by 2. Then 1.236 by 2, how much we can get? 1.236 by 2. This 0.62 or 6 approximately. Oh, it's a 0.61 C. Yeah, that is correct. Into 1 you do. Whatever you done starting, that is correct. C equal 1 farad, that is 1 you do. Then approximately you can get 0.62 farad, 61 or 62 farad. 61 C is correct, no doubt at all. But C value I given here. That is 1 farad. That is 0.62 farad or 61 farad. The C value is given 1 farad. It is not given directly, you take the C. Clear? Like that you have to proceed. If the resistances are given, even if capacitances are given, this is the procedure only how to follow. You have to practice this homework. This homework I am giving. If you have any doubt during solving of this, you share your doubts in my Telegram. Here, instead of resistance, capacitance separately, here it is given impedances. Even impedance is also given, same procedure you follow. Can you solve this problem here? Right? Come on. Identify the repeating elements. This is the repeated. Yes, this is the repeating. This is J4, J4, J6, J2, J6 minus J2. This is Z equivalent. This is also Z equivalent. This is Z. Shall I write like this? This is J4, J6 minus J2. Total impedance, we can add directly. This is J4. This is Z equivalent. Z equivalent. Can you try this? Then Z equivalent equals J4 plus J4 into Z equivalent by J4 plus Z equivalent. Okay. Cross multiply. Then Z equivalent equal to J4 into J4 plus Z equivalent plus J4 into Z equivalent. J4 plus Z equivalent. Now you have to cross multiply. J4 into Z equivalent plus Z equivalent square is equal to J4 J4 J into J square minus 1 minus 16 plus J4 Z equivalent plus J4 Z equivalent. This J4 Z equivalent J4 Z equivalent cancel. Then Z equivalent square minus J4 Z equivalent plus 16 equal to 0. Then from this you have to find the, that is B square minus 4AC. Now try this. I'm adding the slide. Test it. That is Z equivalent square minus J4 Z equivalent plus 16 equal to 0. Then what is Z equivalent equal to? Minus B plus R minus. Minus of minus J4 plus R minus B square. That is J4 square. Minus 4AC. 16 by 2A. And what is Z equivalent equal to? J4 plus J4 square minus 16 minus 64 by 2. Shall I write like this? J4 plus j minus 8 by 2, j4 plus root 80 into root minus 1. Right. What is the root minus 1? You have to write I or j. Then what z equivalent equal to? J4 plus j root 80. Root 80 I am writing, that is 4 root 5 by 2. J4 is common. 1 plus or minus, plus or minus, plus or minus, plus or minus root 5 by 2. Then J2, 1 plus root 5. You take only positive values. If you take positive value, what is the z equivalent strength? J2, 1 plus root 5. Can anybody? What is the answer with that? Final answer? 2.36. How much? How to do this one? 1 plus root 5 into 2. What is the final answer? J 6.47. Very good. That is the final answer. J 6.47. Clear? This you have to proceed. Okay, this also homework for practice. Do this. And this also homework for practice. Do this. Any doubt? Please share your doubts in my Telegram. This also homework for practice. This also homework for practice. Just identify the repeated. This is the repeated. Here, this is the repeated. Just identify the repeated. This also homework for practice. Same order steps. Try this. This also homework for practice. Identify the repeated. This also repeated. And procedure is same. But if the capacitors are series, capacitors are parallel, how to apply? That don't confuse. Resistors and capacitors concept is different. Okay. But this how you can solve this one. You take this 2R now. You write R separately. You leave this R separately. Then you calculate R and R. This is repeated. This you have to write R plus R. You take this is the repeated. Or R and R is repeated, not this one. You have to take R and R is repeated. Take R and R is repeated. This R and R is repeated. Then finally, for final result, separately you can add the R. Finally, you can add the R. Like this, you have to proceed. Clear? Try to solve every problem. If I need out, you can share. Next. These are the different models of questions. The next session will continue with one more model of question, that is if infinite grid network is given and a cube is given, how to solve the problem. Then after that, we go for the nodal analysis and mesh analysis. Then up to now, any doubts, friends? Any doubt? Okay, the next session will continue. Thank you. This is about the today's session. I'm sharing this PPT in my Telegram channel. Please go through. Who are not joined still now in Telegram, this is the Telegram channel, Smart Gate Anchors. All are small letters only, Smart Gate Anchors. How to join this Telegram channel and collect this PPT. Tomorrow there is two more models of questions are there in equivalent circuits. Mainly infinite grid is given, and one more is cube is given. How to answer? Then we will see other one or two questions also, other models of questions. Then go for the nodal analysis and mesh analysis. Who are not joined the Telegram channel, join that and collect this video. Thank you. I'm ending the session.